Ignition sequence starts.
Good morning. Welcome to a bird's eye view of the International Space Station Flight Control Room at NASA's Johnson Space Center and the men and women who are keeping an eye on the operation of space station systems while helping the Expedition 65 crew members as they finish up another work week in space. Commander Aki Hoshide and his American, Russian, and French crewmates have been busy all week with station maintenance and science support, and they are getting set to greet another cargo shipment that's just about ready to launch.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. This week, the space station crew is preparing for the arrival of a cargo Dragon and a pair of Russian spacewalks. During the early morning hours of Saturday, August 28th, a SpaceX Dragon spacecraft will launch from Florida carrying supplies and research experiments to the International Space Station. You can watch the launch live on NASA TV, nasa.gov, and the NASA app. Launch of the cargo Dragon is scheduled to take place at 3:37 a.m. Eastern. With Dragon's arrival to the space station on Sunday, more exciting science is en route to the orbiting laboratory. A new robotic arm is arriving on Dragon, but this one will be working inside the space station. The G-TIE S1 robotic arm will perform activities such as pushing buttons, flipping switches, and plugging in cables on a taskboard. These tests could help in the development of robots to support future crew activities. Researchers will test a commercially available lens that attaches to a mobile device such as a tablet or smartphone to capture images of astronauts' retinas. The retinal diagnostics investigation aims to validate this technology that could be a useful tool in the field of telemedicine, both in space exploration and remote areas on Earth. The MISSY 15 NASA experiment will test and analyze the effects of the harsh environment of space on concrete, fiberglass, solar cells, and more. This is an ongoing series of tests by NASA research centers testing the performance and durability of new materials and configurations. To learn more about these and other scientific investigations on the space station, follow us on Twitter at ISS_research. 2 spacewalks are planned to outfit the new Russian multipurpose laboratory module for science. Cosmonauts Oleg Novitsky and Pyotr Dubrov are set to venture outside the Poisk airlock on Friday, September 3rd, and again on Thursday, September 9th, to prepare the Russian Nauka module for science operations. The new module will serve not only as a science facility, but also as a docking port and as an airlock for future spacewalks. And that's Space to Ground for this week. Thanks so much for watching. We will see you next week.
As Nilofer mentioned, the Expedition 65 crew members are prepared to see a new shipment of supplies arrive at their door very soon on board the 23rd cargo Dragon spacecraft from SpaceX. Packed in there among food and other personal supplies for the astronauts are the materials for dozens of new science experiments. Here's a quick look at some of what's on board. The International Space Station hosts experiments in a whole range of scientific disciplines. Like what? Well, there are the experiments that are just about to launch, and investigations in many classic scientific disciplines. There are also things like research into using 3D printing technology to manufacture biological materials in microgravity, which would allow cell growth in 3 dimensions.
Cutting-edge biomanufacturing aboard the International Space Station. Presented by Science at NASA. Most likely, you're aware of 3D printing, which allows you to design and produce one-of-a-kind pieces for a variety of purposes. But what if you could use that same technology to manufacture biological materials, like new tissue or blood vessels? Welcome to the world of 3D biomanufacturing, a cutting-edge practice on Earth that is being tested aboard the International Space Station, or ISS. Dr. Mike Roberts, Deputy Chief Scientist at the ISS U.S. National Laboratory, explains why the space station is critical to biomanufacturing's future. We've been able to grow cells in a lab for well over a century, but gravity limits that growth to 2 dimensions. Cells can grow outward, but not up and down like they do in the human body. Also, lab cells are often in contact with the glass or plastic that contains them. But aboard the space station, our experiments will be conducted in microgravity. That allows you to build your cell models in 3 dimensions, without being confined to the bottom of a dish, or unable to grow in contact with lots of other cells. Biomanufacturing imagines the ability to someday grow a viable human organ. Organs are composed of specific tissue intersected by blood vessels. Most organs and thicker tissues in the body have a rich, complex network of blood vessels that provide nutrients and remove wastes from the living cells that make up the tissue. We currently lack the ability and the tools to engineer these highly branched, living networks of vessels inside layers of tissues on Earth. Another medical advantage to manufacturing biological parts in space is the potential to bypass the body's immune system. Today, organ transplants from donors are prone to rejection because the patient's body perceives the new organ as a foreign object, and their immune system tries to attack it. But with the ability to grow tissue in space, a person could conceivably have their own cells used to make their new organ, which might avoid the body's rejection. 3 different types of biomanufacturing facilities will be tested aboard the space station. 2 of them perform in a manner similar to a standard 3D printer. They extrude cells in layers to build tissue. The 3rd type uses powerful magnets to position the cells in place. Each of these 3 different approaches to bioprinting in microgravity will be available to medical researchers seeking to better understand how to engineer tissues and organs for use in repairing injury and curing disease on Earth. As Dr. Roberts notes, the 3D bioprinters represent cutting-edge technologies that could clearly benefit health outcomes on Earth. I think the ability to manufacture a fully functioning human organ will take some time, maybe a decade or more, but the knowledge we'll acquire to get there will also create interim benefits as we learn more about cell regeneration in space and its application to humans on Earth. For more inside information about studies inside the station, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.
On the subject of technology research, robotics technology that was originally developed for the International Space Station has found a way to help humans here on Earth in the operating room. The company that developed and built the space station's robotic arm has worked with a medical device manufacturer to create an automated robotic arm that tracks the movements of a surgeon's tools and helps to expedite brain and spinal surgery.
The International Space Station is probably the most fantastic vehicle ever built
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world. And the result will help benefit the people on the ground.
So not only that, but we're also seeing benefits of how we actually assembled the space station.
So the International Space Station in its design was essentially designed like a Lego toy. Lots of big pieces that need to be put together. Some of these pieces are going to be about the size of a city bus.
We needed a way of manipulating or moving these big pieces and very precisely putting them together.
Canada worked with its contractor, which was MDA, and with that company came up with a design that was going to meet the needs of the International Space Station.
The solution to that was using a fairly large robotic arm. And that system ended up being Canadarm2. It could move around the space station, grab payloads, move them to where they needed to be so that the space station could be assembled.
You couldn't have built a vehicle like the International Space Station without a robotic system like this.
And that was when we started talking to Synaptive Medical.
Knowing that MDA has done this before in space, we thought it would be very easy for them to bring that experience and that technology into the neurosurgical area and help us with our medical robotics. We worked with MDA to create Drive. Drive is a robot mounted onto a base that holds a surgical camera that can be automatically positioned to any surgical instrument that's tracked by our system.
What this arm does, it follows you and it tracks you, so it speeds up efficiency.
Ultimately, using the Drive system allows the surgeon to have shorter surgical times, which means shorter recovery times for the patient, and ultimately that's better for the hospital and the patient.
But what the robot does for us is that it allows us to do it safer. You can do it better with less harm to the patient.
The software that runs on the Drive system is directly derived from the software that runs the Canadarm2 on the International Space Station.
Those robotics work with and alongside an astronaut to enhance what they do. So that connection is a very direct and real one.
Right now, it's probably the most used system that we could say is derived from the things we did on Space Station, and we're pretty proud of that.
And I've seen the arm before, we've seen it on the space station, but I never put the two and two together that I'd have the same arm in the OR at some time now.
I think everybody has this dream of how robotics are going to become more and more a part of everyday life. The things that we do with robotics on the space station is basically pushing those dreams forward. And we evolve the system, we gain the knowledge, we gain the experience, the expertise. So this is kind of the unexpected benefits that we get out of doing a program like the International Space Station.
The International Space Station is not the only NASA mission that's creating benefits for those of us who are stuck on the planet. Right now, there are NASA missions measuring water levels in our soil and assessing the impact gravity has on those water levels, all of which generates data from space that contributes to agricultural production on the ground. Our colleagues from NASA's Goddard Space Flight Center have a look at what NASA has to do with irrigation for agriculture, and therefore, the creation of snacks.
Welcome to Snack Time with NASA. Okay. Welcome to Snack Time with NASA. I'm your host, Kathleen Gaeta, and this is my dog, Bowie, and we both really love cheese. So this past year at home, I think we've all learned to appreciate the little things in life, and again, one of those things for us is a nice big cheese board. So today, I'm going to show you how I like to prepare my own and where NASA actually fits on the board. Many people don't know that NASA has a lot to do with the food on your plate. So we're going to highlight some of the foods NASA helps grow using data from space. Now, when you think of NASA and dairy especially, you might think of a freeze-dried ice cream for astronauts, but the connection actually goes a lot deeper. So why a cracker and cheese board? When we're talking about food, it all comes down to water. Corn, soy, alfalfa, it all needs water to grow, whether it's being fed to humans or dairy cows. So when farmers are better prepared for a water shortage in advance, they can make more sustainable decisions, like what crops to grow, how to irrigate them, and where and what to feed their livestock. So here to help explain the connection between space and plate is Matt Rodell, NASA hydrospheric scientist. Hey Matt, how's it going?
Hey Kathleen, how are you? Thanks for having me.
I'm good, thanks for being here. So while I attempt to cube some cheese, can you tell me what NASA has to do with irrigation for agriculture?
Absolutely. So agriculture requires a nice wet soil for growing crops. In order to know how well the crops are going to grow, the farmers need to have a better idea of how much water there is in the soil. And so we've been coming up with better ways for monitoring soil wetness from space. One of the ways we do this is we use a NASA satellite called SMAP, which is an acronym. And SMAP actually measures the wetness in the top of the soil worldwide every day. And this information is vital for understanding how much water is available for the plants, how much water is needed for irrigating the crops. And so it's useful for farmers and land managers and others. It's also useful for monitoring drought. Another mission that NASA has is called GRACE, which is another acronym. And GRACE is really incredible because it uses measurements of Earth's gravity field to understand the amount of water on and in the land surface. So we can even measure things like the amount of water in the underground aquifers, deep underground. This is vitally important because groundwater is one of the main sources of water for agriculture. It's also a source of water for people who have wells in their backyard like I do. So when I turn the faucet on, that's groundwater coming out. And in fact, about half the produce that we eat, we have groundwater to thank for that because it's used for that much irrigation. This includes things like the wheat in your crackers, soy, fruits and vegetables on your platter, etc. So all of these things NASA's doing are really contributing to our understanding of the water availability that's critical for irrigating all of these crops.
Interesting, and a good reminder that this cheese board needs dressing up. So I have edamame in front of me, and what I believe to be the most underrated part of a cheese board, which are carrots and olives.
Yeah, those are pretty water-intensive crops, and they're grown in the Central Valley, which is someplace where proper water management is really critical. I see you have some grapes there too. Speaking of grapes, NASA has an ongoing project with the U.S. Department of Agriculture and vintners in California called GrapeX, where we're using data from Landsat satellite along with multiple other space and ground-based observation sources and advanced computer models to help to schedule irrigation for these vineyards and therefore preserve the precious resource water. It's really precious in California, where there's an ongoing drought right now, as well as most of the American West. We use data from multiple satellites to monitor drought. This helps the end users like the farmers and the ranchers and others that are interested in agriculture to better prepare for drought and to better plan how to mitigate the effects of drought. Drought's going to become even more important in the future, we believe, with climate change. It's likely that in some parts of the world, droughts are going to become more frequent and more intense. And it's possible that the dry parts of the world will get drier, wet parts of the world will get wetter. That's where NASA comes in. So we're helping with not only the current monitoring drought, but the forecasting of near current drought, and then predictions of how climate is going to change in the future and how it's going to affect our water resources.
Well, Matt, it looks like my cheese board's done. What do you think?
I think it looks delicious, and I can't wait to go start my own lunch. Thanks so much for having me, Kathleen.
Thank you for joining me, and thank you everyone for watching. I hope you learned a lot. I know I did, and I hope this episode wasn't too cheesy for you. Okay. Good?
In addition to being the hands-on laboratory assistants for science research done in space, the International Space Station's crew members use some of their time to share the experience of being in space and to help students learn about scientific concepts as they study science, technology, engineering, and math. For example, astronaut Scott Tingle put together this demonstration video about the importance of nutrition for men and women who are of this planet, if not on it at the moment.
Hello, and welcome to the International Space Station. My name is Scott Tingle. Here on the space station, we live in a microgravity environment, which which makes eating here a very unique experience. To stay healthy, we have to maintain a nutritious diet, just like we would back on Earth. Let's go take a look at some of our food and drinks and check out our meal preparation area. During long-duration spaceflight, we have to make sure that we receive enough energy, proteins, and vitamins. Our food lab back on Earth makes sure we get plenty of each as they carefully prepare, test, and package everything. We combine all of this excellent nutrition with exercise to ensure our bodies stay healthy and strong while we're here. We eat 3 square meals a day, just like we do on Earth, and maybe throw in a snack or two. One of my most favorite foods to eat are natural raisins. Here on Space Station, we have to keep our calories up if we want to get all our work done. And the carbohydrates in these raisins really help. And they're kind of fun to eat, too. And how do we stay hydrated in microgravity? With these special pouches. They're filled with water, and we use a straw that has a one-way valve that prevents water from floating out of the pouch while we're not drinking from it. Here's a liquid drink. This is a tropical punch for today. I love drinking fluids on station. Here on station, we have a pretty cool food preparation area. We have a place to get fresh water for us to drink or to put in our rehydratable foods. And we also have an oven to put food in. We pick out some of our favorite foods, chicken fajita for me. Put it in the oven. Close the door and turn it on. In about 15 minutes, I'm gonna have a warm meal. Thanks for exploring a little nutrition with me. I'm gonna send you back to Earth so you can create your very own astronaut menus. See you again soon.
Quite a few of the astronauts who have been to the International Space Station report that getting a view of Earth from orbit can have a profound effect on a person. One of them is Nick Hague, who says he has a new perspective on a lot of things after getting a wide-angle look at the whole planet from 250 miles up.
I think the first time I really got to soak in the view was in the cupola on the station, and to just sit there and think. You know, the colors jump at you, the perspective jumps at you and challenges you in multiple ways. I think it evokes, you know, all these different sensations. The largest emotion that I'd feel out of it is I felt this connection. All of humanity's here on this globe. You realize just how special the place we are is, and you feel that connection. And when you see the impacts that we can have on the land, it gave me this overwhelming sense of stewardship and just wanting to try to, you know, come back and take care of the planet a little bit better than I had before, and help convey the message that, you know, we're on this place together, and, you know, we explore space together, but we also live here on Earth together and need to work together to make sure the Earth stays as pristine as it can be. During my third EVA out there, I can remember we were working on the front of the space station. And so I finished up that task, and then to catch my breath, I just kind of propped myself up on the front of the station looking forward, and it's just the Earth arced out in front of us, slowly gliding by, and I felt like, you know, I was just riding the station through space. You know, it's stuff you think about, you know, you see in the movies, but it's this overwhelming experience of, I can't believe I'm here doing this, and that's going below me at the, you know, that I get to see this. So I can distinctly remember waking up one morning, couldn't sleep for whatever reason. It's like 4 in the morning. I was like, hey, we're in a night pass. I'm gonna go down to the cupola. I'm gonna drink my coffee and just stare at the stars. And there's just so many. And the longer you stare, the more you see. You start with just the big bright ones until your eyes start to adjust to the dark, and then they open up a little more. And when your eyes open up a little more, you see all these smaller little stars. And then once they open up enough, then you can start to see all of this cloudy structure, and you realize that the depth of what's out there, I can only see the tip of the iceberg. So it definitely puts you in your place in terms of, how big am I? How big are we collectively as humanity sitting here on Earth? Being able to look at the Earth from that vantage point and simultaneously see myself as part of something so small in the great cosmos, but also part of something so large as the Earth that's below me, made me realize at a deeper level that I may be one small individual that's part of humanity here on the ground, but I can still have an impact, and I can have a large impact but still be something very small. That balance of perspective has given me a sense of empowerment that I hope that everybody could share in terms of you can make a difference. The Earth is an amazing place. It is unique. When you look out into the depths of space, you realize just the vast ocean of darkness, and we're on this little island, and we're on it together. And we need to figure out how to work together for the benefit of everybody.
If you want another look at any of the stories you saw today, you can always find them on YouTube and Facebook. They're in there along with lots of other great features on a wide variety of NASA topics, so have a look around. Now, if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. It's our weekly show talking to folks involved in all areas of space exploration. Today, Gary Jordan returns to the timeline of the upcoming Artemis 1 mission, the end of that timeline, in an interview with Artemis 1 Recovery Director Melissa Jones to learn about how NASA plans to retrieve its Orion capsule after it returns from orbiting the moon. Go to nasa.gov/podcasts for this week's episode. All the previous episodes are there too. So is the full library of all the NASA podcasts, and you can find them all on Apple Podcasts, Google Podcasts, and SoundCloud.